Hello everyone, very good afternoon all of you. Yes, how are you all? Yesterday we learned the best first search algorithm. Today we will learn the remaining algorithm. As we discussed yesterday, there are so many algorithms and questions are coming from those algorithms, and comparison and comparative analysis is important. So here I came so that before exam how the comparative analysis is required, we will do the comparative analysis of all the algorithm so that it will be easy to understand and you can do those you can understand those topics also. Okay, and whenever my video will be get stuck, please let me know because there is some device or driver problem, some issue is there. So whenever you will see that my video is stuck, please tell me that ma'am your video is stuck. So here best first search, yesterday you understand very clearly and I hope there is no doubt now. And where we are, what was the concept of best first search? That best first search was the combination of breadth first search and the depth first search, right? So that we discussed yesterday, and after that here we learned that key best first search is the implementing with priority queue and gives the solution without calculating all the nodes. Here these are the points you have to remember so that you can do the question. The depth first search gives solution without calculating all the node, while the breadth first search is solution without search guarantee to the procedure does not cut. But best first search is the mixer of these two so that licenses exchanging between the path. At each stage, the node among created node, the best appropriate node is chosen for facilitating expansion. So which one I should expand, for that I am going to choose it, and then hence can flip between the depth first search and breadth first search. So whenever it's required BFS, it will do BFS. Whenever it's required DFS, it will do DFS. So here the time complexity is order of b to the power d, and space complexity is also order of b to the power d, where b is the branching factor and d is the depth. Okay, these are the points. The comparative study is very important. The comparative study between all the algorithm, that is we are going to do now today. Okay, so yesterday we did the analysis, that worst case of the best first search and the special cases, that is greedy best first search, and that application is game and the web crawler. Here that is the application of best first search. And when we did the greedy best first search, what was the greedy best first search? Greedy best first search attempted the find most promising path from given starting point. If prioritize the path, then the most promising will be actually which one is shorted. Means greedy, what is the main concept of greedy? That it will search all the possible solution. Out of them, which one is minimized, that it will take. Right? Out of them, which one is the best one, minimized one, that is going to take. That is the main concept of the greedy. That's why it is called the greedy. The algorithm works evaluating cost of each possible path, then expanding the path with the lowest cost. That is the main point, and I will request everyone, as I told yesterday, that prepare a list. I am going to provide you a list of complexity and whatever the consistent list is required, that we will discuss. And what are the points I am focusing, those points write down in your notebook, so that the question on the searching algorithm, comparison, matching question you can do. Okay, must note it down now only. The algorithm works using the heuristic function. Here in greedy also we are using heuristic function to determine each path which one is the most promising. So heuristic function takes on the account of the cost of the current path and the estimated cost. Both the current path and the estimated path, both will be the main concern of the greedy best first search. So the current path lower than the estimated cost and the remaining path, then the current path will be chosen. Whatever you already traverse, if the current one is the minimum out of them all, then you are going to choose that. This is the way the greedy best first search was working, right? That is the way how it was worked. This is the way it was worked. You choose the evaluate the cost, all the possible path, repeat until the goal, and then algorithm use the heuristic one, and here it will take, and after that it will be chosen. That was the things. So your difference between the hi, good afternoon everyone. I hope I am audible, visible. All are telling good afternoon. Yes, I am here. So it was your disadvantage and advantage. We did an application of the greedy was pathfinding. The applications are very important, and advantage and disadvantage is also important, that I already discussed yesterday. Advantages are simple, easy, fast, efficient, low memory, flexible, efficiency. Disadvantage, lack of completeness, very important. Questions are coming from here. Which one it is complete one, which one is not complete, which one is lack of completeness, which one is optimal. For here the questions are coming. Why it is not completeness? Because whenever a solution is telling complete, when a solution exists, it will give you. But here in the greedy best first search, it is possible that it can stuck into the cycle. It can stuck into the cycle, and that's why it was a problem of greedy best first search, and it is a very important point. Okay, this is the very important point. ठीक है मैम, I am preparing for GATE data science, new subject started in this year. Suggest each such AI PYQS. Yes Kunal, I am planning to start regarding GATE also after this December, because GATE exam in the month of February. So my plan is that January, total January, month of January and the end of December I will dedicate for the GATE. How much possible I will try to help the GATE student also. So after this 7th December NET exam will be over. After that I will focus on the GATE. Okay, so hope for the best. Let's see how much I can help the GATE student. So heuristic function, this is the heuristic function. So greedy best first search required the heuristic function in order to work here. And here it is the local optima problem, and the inaccurate result is also there. These are the main disadvantage, and these are the applications. Very important. Very important. Pathfinding, machine learning, optimizing, game AI, navigation, and natural language processing. Next one is the uniform cost search model. What is uniform cost search? Yesterday you saw the question on uniform cost search also. Okay, so here what is, and this class will be regarding exam special, like all the algorithm analysis completely together in one class. That is my planning. So that's why I prepared this class, so that all analysis will be done together. Okay, so uniform cost search expand the node with the lowest cost path. Which one is the lowest cost? That will be expand. So you learn the A star algorithm, right? So with the uniform cost search we will compare the A star, so it will be easy for you. So it implement using the priority queue. Concept of priority queue we learn in the best first search. It is also using the priority queue. Here also priority queue is there. And calculate the cost of every node. Consider this equation. Remember the equation. Very simple equation, like the disaster algorithm. In disaster algorithm also we utilize this type of equation, that U where you are V plus WUV. That was the concept of your disaster algorithm. That is the same concept here, where you are plus the cost to traverse. Okay, so CM is the cost of the current node and CN is the cost of the previous node. Out of them we are doing CN comma M is the weight of the edge. Between N and M, what is the weight of the edge, that will be calculated. The successor can be removed which are already in the queue from with the higher cost. As we are preparing the priority queue, so which one is the higher cost, that will be removed, and which one is the lower cost, that we will take. Same concept here also, open and closed two queue we will maintain. So here the time complexity, you can see order of this time complexity, remember. Okay, questions are coming from here. Order of b to the power 1 plus c by epsilon. Here where this is the activity cost of the at least epsilon, at least e, epsilon not e means that is only you can see. Okay, so here you can see an example. I hope this example will be visible to you. I am zooming it little bit. Yes, you can see here, this is visible. This is visible to everyone. Yes, can you change the pen color? I can change the pen color. Is it disturbing? Sometimes students are telling to highlight, so that's why I am using white, yellow. Red is okay. Red is okay. Sometimes students are telling that ma'am use highlighter, so I use the highlighter. Is that okay now? Acha, see that. Here this is the source and here is the goal. From here I have to start and I have to reach to the goal node. Okay. Now how it will work? How this will work? I give it in the single page so that we can understand. So I will start from this one, that is my current one. In the current one, what is my cost? Now 0. I am here in the starting node, that's why 0. And only one option is there. So I will put it into the closed list, means this is now visited. So I put it into the closed list. Whenever I put it into the closed list, what are open now? This is open and this is open now in front of me. So 2 and 5 is open. So what will be the cost? 0 plus 2, that is 2 here. Here 0 plus 1, that is 1 here. That's why the cost of 2, 5 will be 2 and 1. Out of them, which one I should choose? Definitely 1 I should choose. So that's why we will choose this one. I will not choose this one. Right. Now I am going to expand this one. Whenever I visited this one, what are available to me now? Available to me now. Which one are available now to me? See that already 2 was available. Already this was available to me. And now this is also available to me. Don't do mistake that ma'am 6 is also available. No, 6 is not available. Check the arrow. Here is the arrow 6 to 5. 5 to 6 arrow is not there. 6 is not available to me. What is available? 5 to, because it is the directed graph. It is not the undirected graph. So 5 to 9 there is the path, but 6 to 5 there is no path. So that's why what are now available to me? Previously 2 was already there and 9 is now added. Okay, this is the new one which is added now. Now what I will do? Here I will calculate 1 plus, this one is again 1. So 1 plus 1 is 2. And from here to here, that was already there. This is already there 2. So now it is 2 and this is 9 also 2. Out of them, the previous one I should choose. As it is the priority queue and as per the yesterday concept only, which one will get the first chance, which one is already present. So it is already present. This is also 2, this is also 2. Out of them I am going to choose this one. So now 2 came to the closed list. Whenever 2 came to the closed list, now which are open to me? This is also open to me and this is also open to me. Right? Yes. So now 9 was already present, that is 9 2. Now from here to here I will do the distance 3 plus 2. 3 plus 2, that is 5 now. And from here 2 plus 1, that is 3 now. So you can see 6 will be 5 and this is 3. Out of them, which one I should choose? I should choose the 9 because it is now 2. So I should choose this one. Whenever I am choosing this one, which are open now? 10 is also open now. Already this was present. After that, the 10 is also open now. What is the value here? It was 2 plus 8, that is 10. And I will maintain the priority queue. As per that, now here you can write this one as per this way. 3 is 3 now. Then 6 is 5. Then 10 is 10. Out of them, which one I should choose? This 3 I should choose. That's why I will choose the 3. So now I am here in this 3. Which one is open now? Now 4 is also open, says 7 is also open. Now I will calculate here. 3 plus 2 is 5. No, 7 is not open. Sorry, 7 is not open because 3 to 7 there is no path. Check very carefully. 3 to 7 there is no path. 7 to 3 there is the path. 3 to 2 there is the path. 3 to 4 there is the path. Right? So that's why only which one is open to me? Only this one is open to me. That is 4. And previously it was already there. So now again I will maintain the priority queue. So here 4 is the 5 and 6 is also 5. 10 is also 10. Out of them, which one I should choose? I should choose the previous one. 6 is also 5. 4 is also 5. But 6 was already present previously. That's why I will visit 6 now. Right? So that's why 6 is coming into the closed. Whenever 6 came, then what will be happen? 7 is also open now. So here I will calculate 5 plus 1, that is 6. So now 7 will be 6. 4 is already there, 10 is already there, present. Now after that, what will be happen? 4 I will choose because this is the minimum one. So I am going to choose 4. Whenever 4 is chosen, then this one is also visited now. So 4 plus 1 is 5 now. So in my list, 4 plus 1 no, this is 5. 5 plus 1 is 6 now. So now you will do 7 equals to 6 was there. Then 8 is also 6. 9 is also 6. But 7 was previous. So I will choose 7. Whenever I am visiting 7, then the 11 is also open now. Whenever it is open, what is the value? The value was 6 plus 10, that is 16 now. So previous one was 8 was 6, then 9. I am going to choose this one 8. Now I will visit 8. Whenever I am visiting 8, then this is open now. And I will calculate here 6 plus 15, that is 21 now. Now out of that, which one I should choose? This one, that is 10, 9. So I am going to select 10. After that, already all are traversed. See that all are in the queue. Already these are happened. So now I am going to choose which one? Out of that 11, now you can update the value. See that previously it was 16. But via this path if you are going, then this will be updated now. Here is the updation, just like the disaster algorithm. We learned the disaster algorithm just like that. When you took 11 via 7, then your answer was coming 16. But when you are coming via 10, then what will be your answer? Then your answer will be 10 plus 3, 13. That's why now this will be updated to 13. Right? Now this will be updated to 13 here. So whenever it is updated to 13, now I can choose this one. So that is 11 is 13 now. Yes. Now this one was 21. This is also updated now because now this one will be updated to 13 plus 1, that is 14. So now 12 will be updated to 14. Actually this will be updated to 14. So that's why final value will be 12, that will be 14. So it will be now updated to 14. In this way we will reach to the goal node. How I reach to the goal node? Ultimately from the start node to the goal node. How I reach? In this way. Now if you are trying to find out the way that how I get it, through which path ultimately I am able to reach, see that ultimately you will get your path. After this way, the algorithm, when you will complete the algorithm, then easily you will find the path, through which path I traverse and how I am able to reach. See that ultimate answer was coming what? 12 was 13, right? So how I reach? 1 to 5. Then from 5 I have traversed that 2. That one was traversed. Then 9. Then 5 to 9 I traverse. Right? Then after that the 3. So here I was trying to traverse 3. After that 6. So here I was coming to 6. Then the 4 to 5, there was 4 to 4. So 4, fourth one was where? The fourth one here is the fourth. Now after that 7 is 6. So how I am able to reach to 7? This is the 7. Now after that 8 is 6. So I am able to reach to 8 by 6. Now here 10 to 9, this is the 9. Then after that 11. Then after that 12. So actually these are the path did not reach to the goal. Ultimately through which path I reach to the goal? I reach to the goal ultimately from this path. This one, then this one, then this one, then here, then here. Right? In this way I am able to reach to goal. So that was total value. What was the total value here? Here whenever I make the green color, then it was hiding. You can see this one was 1, then 1, 8, 3 and 1. So what is the value? 0 plus 1 plus 1 plus 8 plus 3 plus 1. So 1 plus 1, 2, 10, 13, 2, 10, 13 and 14. Is it there any mistake? Why it's coming 14? 14. 12 was coming 14, right? Final value was 14. When we came to here, it was 14. Right? Because this was 13, then this was coming 14. This was 13, final value was 14. So that's why I came as 14. Clear? This is the way. This was 0, that was the 0 position. After that 5, that is 1. Then after that 9, this 9 was 2. Then after that it came to 10, that was 9, that is 9. Then 11, that 11 is 12. Then 12 is 14, that was 13, then 14. Clear? Is that clear to everyone? Yes. Wait. Here I did a mistake. Wait. Here the mistake is, this was 9. 9 plus 3 will be not 9 plus 3 will be 12. Right? Here I did a mistake. Here it will 9 plus 3, that is 12. I did the mistake. I took this 10. 10 was not the value, right? 9 was the value. So 9 plus 3 will be 12. Then 12 plus 1 will be 13. So that's why answer is 13 here. Now it is come. Now it is over. Now it is correct. Yes. Previously when I did, then I did a mistake. 10 plus 3 equals to 13. That I took this value. This value not. This is the node number. This is the cost. 9 is the cost. So that was a mistake by my end. So it will be 9 plus 3, that is 12, then 13. So using this way I am able to reach. So that's why my final answer will be here 13. My final answer will be 1 plus 1 plus 8 plus 3 plus 1. So 10. Where is the mistake? 1. This is 0 plus 1, that is 1. Then 1 plus 1, 2. 2 plus 8. Previously I was correct. I am making confusion. Sorry. 8. Then 1 plus 1, 2. 2 plus 8, 10. 10 plus 3, 13. 13 plus 1, 14. 14 only. Yes. So here is a mistake. It is not 12. It will be 13. This will be also 13. And this will be 14. Final answer is 14. Clear? Is that clear? Yes. Take the minimum. Yes, I took the minimum only. Through this path only we are taking minimum. Because if I am visiting, when I was visiting through this way, then path was coming maximum, right? Then it was coming maximum. So 14 is the correct answer. Otherwise when we explore, then this was coming more. This value was coming more. Here this value was more. That was I did updation. Yes. So this is your uniform cause search. This is called the uniform cause search technique. I hope uniform cause search technique is clear to everyone how it is working. So this is the algorithm, and that's why here the complexity will be this one. Okay. The activity cost, because when we are comparing, that activity cost will be there. We have to think about that activity cost also as epsilon value. Okay. So here the uniform cause search model, space requirement is less and intelligence is not required. Intelligence is not required when evaluation function, that is heuristic function, is not required. Here not required any heuristic function because it is already given to you. The values are already given to you. No heuristic function required here. Solving the maze problem. This problem was a maze, like a maze problem, right? So to solve the maze problem we can do it. Path finding also we can do using the uniform cause search model application. Is that clear to everyone? Yes. Now if you compare with the A star algorithm, how the A star algorithm is working? A star algorithm joins highlight of the uniform cause search. It is using the technique of the uniform cause search model and the pure heuristic search to the productivity calculate the optimal solution. Here the extra thing we are adding, that is the heuristic search. In uniform cost model the heuristic value was not there. But here we are adding the heuristic value. Here we will add the heuristic value for computing the cost in every node. Here is the Fn equals to Gn plus Hn. That we did, right? Khn is the heuristic value. So the extra addition is here. Out of the cost and the Hm, out of them we are going to choose any one of them. Cm equals to Cn plus Cnm comma Hm is the heuristic function. Fm is the compute cost that is already we traverse, as I told already here. Whenever it is my starting node and I am here, this is my current node and this is my goal node. Already I traverse this distance, this is known to me, and from here I am calculating a heuristic and now I am adding that heuristic, right? So most reduce aggregate cost and most reduced value of the f chosen in each node for the expression. For expansion, now I will add the heuristic also. So the Euclidean distance used when allow the move in any direction. There are two types of distance. We can use the Euclidean distance also, or we can use the Manton distance also. Manton distance means used when allowed to move only 4 direction, that is right, left, top, bottom, all the direction, or maybe diagonal distance also. If we are allowing only one direction, that allow when to move any direction, any of the direction I am going, then I can choose the Euclidean distance. But the Manton distance will be taken when it's allowed move only 4 direction, either right or left or top or bottom or diagonal. Then we can use that move in 8 directions, same as the movement of the king in the chess. That's why this is the A-star algorithm implementation. Different game are there. So it is the chess game. In the chess, king can move everywhere, right? That was the move. So here we have to utilize the Manton distance. Are used as a heuristic function. Now the heuristic function is required because I can move every direction. So in every direction, whenever I am moving, then I need the heuristic value also. If the value of f of two node is the same, then the node having the lowest h, that is the heuristic value, is chosen from the expansion. Out of them, which one is the lowest one, that one will be chosen. After doing this class, your all the algorithm will be more clear. It is my guarantee, because I also prepared like a analysis, so that you can relate all the algorithm and you can go in depth of more the algorithm, because exam is asking question in more depth. So that's why we have to go also more depth. Okay, those who want to learn in more depth, definitely your concept will be getting more clear. Is it or not? Are you getting more clear concept, that you are able to relate all the algorithm? Yes. So calculation end when the objective is decided for the expansion, when it is ended. Admissible heuristic function, that is hn less or equals to h star n. Whatever heuristic value is there, and previously whatever till now we got, out of them which one is less or equals to, from here already question came. Only less than not, equals to also, less or equals to. Bring visited node back from the closed list to the open list. Everywhere the concept of open and closed list is there. Here also the concept of open and closed list will be there. And we will come to the optimal solution. Time complexity will be order of b to the power d. Space complexity is also order of b to the power d, where b is the branching factor and d is the depth of the solution. Okay. Yes. So here is the example. With this example, same example, see that here also the same example I took, so that you can relate it. This is the same example of the A-star algorithm also. I will start from here and I want to reach to the goal. What is the main difference? Difference is there. These are the heuristic value. I added the heuristic value here. What was not there in the uniform cost search? When we did the uniform cost search, only we took these values, right? But here I took these heuristic values also. With use of heuristic value, now we will go ahead. That is the extra addition here. You are able to relate A-star algorithm and the difference of uniform cost search. Yes. So how it will work? Start from the source node, add it into the open list. I will start from here and I will add it into the open list. Now explore all the adjacent node as it is. All adjacent one I am trying to explore, and I will put it into the open list. Same concept. Where is the difference? Calculate the cost for the all node discover in this step. We will calculate all the cost whatever newly added and place them into the open list in increasing order based on the cost. Same way as per the ascending order or increasing order we will place it. Now move the current node from the open to closed. Whenever all adjacent list is prepared, then current node will be placed to closed node. Same concept. The first node in the open list will be the current node now. Which one is the minimum? That one will be the current node now. Same way repeat this step till how long you are not able to reach to the goal. The closest list give the shortest distance. Concept is same. Then how? What is the difference, ma'am? Difference is here. Here whenever you are starting with 0, but here I will start with 12. Because here 0 plus 12, that is my heuristic value, will be also added. That's why this is 12 now. And now I am placing it to the closed. When adjacent node, this one and this one. Now I will add what? Key here is the heuristic value. These heuristic values will be added here. So now I am, whenever I am trying to visit, till now this is not visited. Before visiting you don't know the heuristic value. Don't do the mistake. Here heuristic value only you can do. This heuristic value is telling what? I am here. In the start node, this heuristic value is telling me within 12 kilometer I can reach to my goal. Okay. Whenever you visit here already, then if it is 10, then you can understand, okay, with the 10 more 10 kilometer I can reach to the goal. That is the meaning of the heuristic value. So that's why when you will visit it, then only you can do the heuristic value, otherwise not. Yes. So now this will be updated. How this will be updated? Here you can see that this value 10 plus 12, 10 plus 2, 12, and previous one was after that 2 already 0 to 2. This is already 2, then 10 plus 2, 12. Right? So that's why this value will be 12 itself. Whenever you are coming to 5, then you already traverse 1. So 12 plus 1, that is now 13. That's why 5 will be 13. Yes. Out of them, which one I should choose? I should choose this one. So that's why it will be in the closed. Now I am coming to 12. This is not, sorry. I will come to 10. That is 2. I will come to 2. This is my current one. Now from here, which one will be open? This one and this one will be open. From here I will add the value. That is, what will be values will be added. Here this 3 will be now 16 plus 3. Because previously this one already here. Now 16 plus 3, that will be 19 now. And this 6 will be what? This is will be 12 now. So that's why now this is 5, 13 and 6. Now I will visit this one. Same way I will explore this one also. Then I am in the 5. Concept is same. Only extra addition is the heuristic value. Just like the uniform cost search, same way we are going ahead. Extra addition is what? The heuristic value. Other than that, no extra addition. Only extra addition is the heuristic value. Right? Yes. So finally you are able to reach to the goal node with the value 13. Same way. Through this path, same path only you will be able to reach. But it will be not 13. Answer should be 14, I think. Out of that same mistake I did here, maybe, because same way if it is coming, then it is the goal. Okay, so main concept is clear. All the algorithm I am not discussing. Concept is clear. Yes. So A star previously also we discussed, that's why I am not discussing again more. So traffic navigation system, game, finding the shortest path, real time path replanning of an unnamed surface, these are here under A star algorithm. Yes. Yes. Now see the next one. The course will be till December. Till the month of December. It is the PYQS MCQ course is going on. So it will be till end of December. Okay. Next one is the depth limited search. What is depth limited search? DLS, depth limited search, is the variation of DFS only. Yesterday we discussed DFS. Where is the difference? Difference is there how long I should go ahead. The depth will be mentioned that you can go to till depth 2 or you can go to till depth 3. The limit will be there. Whenever the limit is there, that's why the name is depth limited search. Any other difference is not there. Same way as per the depth first search, only the difference is limit L. How deep and the depth first search can go. So we can guarantee that search will terminate either successor or failure. Either I get the success or I am not getting success. Till this depth you can go. That is like that. Your age is 35 years for the women. Till that age only you can try for JRF. After that you cannot try. You will get success, that is also okay. You will not get success, that is also okay. After 35 years you cannot try. There is a age limit. This is the limit here in the depth limited search. Okay. So if there is a least goal start, so then it will be the L. So algorithm guarantee to find the goal state, but not guarantee to find the optimal path. Okay. In the less depth it can guarantee, but it cannot guarantee that it is the optimal path. So the space complexity will be order of BL and time complexity will be order of B to the power L. Actually preparing for state exam. Okay. Okay. If you have the SAT exam, let me know. I will try to extend. Which SAT exam? Most of the SAT exam are ending in the month of December. If there is any SAT exam which is not ending in the month of December, then definitely I will extend in January also. Okay. If there is, but as per my knowledge, all the state exam is ending on December. If there is any exam not ending, then I will extend. Don't worry. So DLS is clear. DLS, depth limited search, is clear to everyone. Those who are watching, I am asking them. Those who are watching, yes. Okay. ठीक है? चलो. Okay, Srinivas. If AP set is there, AP is assistant professor exam. Yes, I will extend. I will try to extend. I will confirm you after the class. If there is the option to extend, I will extend. I will try from as a admin end. I have to check. As a admin end, I will check. And if it is able to extend, I am extending after the class only. I will extend till January. End of January, okay, or end of February, so that those who are preparing for GATE, they can also avail. Then happy, end of February I will extend for you. कर लो सब, ठीक है। चलो, सो डेप्थ फर्स्ट इटरेटिव डिपेंडिंग सर्च, डेप्थ फर्स्ट इटरेटिव डिपेंडिंग सर्च, सो द इटरेशन इज देयर, ठीक है। इटरेशन कैसा है, DFIDS, remember the short form also, sometimes in short form also they can ask. It is a one variation of depth limited search. All are related, all are related. With the relation, if you are learning, then everyone will be clear to you. Haphazardly if we are learning, then it is not clear. One by one, step wise, whenever we are learning, then it will be very clear and you can relate all the algorithm. Okay, so if the lowest depth of the goal state is not known, we don't know what is the lowest depth, then we can always find the best limit L for the DLS by trying all possible depth. That is the thing here. Depth limited was fixing a depth, that is you can go to till depth 2, but it will by a iteration it will increment the depth. First it will try to depth 0, if I am getting then fine, then I will increment to depth 1, then again try, then increment to depth 2, then again try, like that way iteration wise increment the depth and then do the depth limited search. So what is the concept? If you know the DFS, so it is like a layer by layer we are adding. Yes, so what are the layer? First of all, concept was DFS, depth first search, we learned yesterday. After that it is depth limited search, that I am limiting a depth. After that I am adding another wrapper on that, कि I will add the iteration as a depth DFIDS, depth first iterative search. One by one iteration wise I will increment the limit one by one and then I will run the same concept. Okay, so when I can stop, when I achieve the goal. So what will be the advantage? Unnecessarily you are not going till the end. How long required, that long you are going. If you are fixing statically कि this is my depth, there is the chance you will not get the goal node in that depth. So that's why I am adding an iteration. Okay, in this iteration I am not getting, so let's try for the next depth. Next depth also you are not getting, let's go to more depth. That is the simple concept. Yes, so after appearing the wasteful, because the DLS less same thing is given here, whatever I told here. Clear? Is that clear? Yes, expand the state many times. However, the practice most of the time spend the deepest part to the search, and algorithm actually combines the benefit of the DFS and BFS. That is one by one level I am increasing and I am going more deeper and deeper. Because all node expanded in each level and algorithm complete the optimal like the BFS, but modest memory requirement in the DFS. Exercise: if we had penalty of memory, could we avoid the expanding of the top level many times? Can we do it? Yes. So the space complexity will be order of BD, where DLS equals to L equals to B, and time complexity will be order of B to the power D as BFS. So better than the DFS. It is better than the DFS here. As per the BFS, here is the time complexity. ठीक है? You are able to relate? Yes. Can we continue? Is it? Can I continue the next all the algorithms so that all algorithm will be together and you can relate everything? Yes. Those who are watching, tell me no. Yes. Is it okay? Bidirectional search. The idea behind the bidirectional search is the search simultaneously both forward from the initial state and backward from the goal state. It is more intelligent. ये और बहुत चालाक है कि चलो स्टार्ट से भी करो, गोल से भी करो. स्टार्ट से चलो फॉरवर्ड डायरेक्शन में, गोल से चलो बैकवर्ड डायरेक्शन में. ये बहुत स्मार्ट है कि both direction we will try, and whenever in middle I am getting the answer, I will stop. Maybe in the middle I am getting the answer, I will stop. That's why it is the bidirectional. Initial backward from the goal stop, then two BFS search meet in the middle. We are applying here in between the BFS, that is breadth first search. Two BFS search meet in the middle, then I will stop. So this is not always going to be possible, but likely to be feasible if the state transition are reversible. If it is reversible, then only it is possible, otherwise not. So the algorithm computes the optimal, algorithm is complete and optimal. From here question are coming. Which one is complete, which one is optimal? Yes. Since the two search, that is depth, that's why it is d by 2. That's why the time complexity will be here d by 2. At a time I am doing both sides. And the space complexity will be order of b to the power d by 2. So time complexity will be also order of, time complexity is order of b to the power d by 2. Here is little bit improvement, and space complexity will be also order of b to the power d by 2. That is a improvement. Yes. So however, if there are more than one possible goal state, this much factor into the complexity. Okay. ठीक है, clear. Here is the repeated state can be there. It is the detail of this, avoiding the repeated state. Now it is your comparison. This is the comparison between the uninformed search. Till now whatever uninformed search we learned, BFS, DFS, DLS, DFIDS and BDS. DFIDLS means depth first iterative depending search. DLS means depth limited search. BLS means bidirectional search. This chart will be very helpful for your exam. Very helpful. Write down this chart. So completeness. BFS is complete. DFS is not complete. DLS is complete if L greater or equals to D. DFIDS is also complete. BDS is also complete. So which one is not complete? Only DFS is not complete. Yes. When we should say that it is a complete or not, I am coming. Here the BFS is optimal. BFS is optimal. DFS is not optimal. DLS is not optimal. This is optimal. This is also optimal. Time complexity, order of b to the power d, order of b to the power m, order of b to the power l, order of b to the power d, order of d by 2. Space complexity, order of b to the power d, bm, bl, bd, b to the power d by 2. Okay. Clear? Must write down. Question are coming from here. I already shown you yesterday. Yes. Now what is called the optimality means solution provided by the algorithm will always be optimal or not. That is optimality. Completeness means is that the algorithm is complete if it terminates with a solution when it exists. If there exists a solution, it is providing you a solution. That's why it is called the complete. Otherwise, if sometimes it is not giving you solution, means that is not complete. That's why DFS sometimes cannot give you the solution. That's why it is not complete. Okay. Here are some other algorithm, BFS, DFS already I told. Uniform cost search. Uniform cost search, this is the complexity, and optimal complete also. A star algorithm, this is the complexity and it is optimal and completeness also. BFS, greedy. Base first search. This BFS means this is the best first search, not the breadth first search. This is base first search. Optimality, no, optimal, not. And here it is completeness, yes. It is the completeness, according to the completeness it is yes. ठीक है? Clear? I hope today's class will help you to go in depth of the algorithm. Yes. So what we can conclude? We can conclude that heuristic search is more efficient and acceptable than the blind search. For example, the expanded of the open close list in the uniform search as the A star. In A star we add that. It is clear that uniform search 11 nodes are required to expand to reach to the goal state, while in A star only 6 nodes is required to expand. You can go back to the example and you can try that how it is expanded. If you came here to the comparison, here it was required to so many nodes to expand, but here in the A star algorithm, when we, where is the A star? This is the A star. Uniform search is this one. In uniform search so many nodes was there to expand, but when we came to A star, then less number of nodes are there to expand. That is the advantage here. Less number of nodes. These are the number of nodes to expand. But here very more number of nodes are there to expand. And this is possible because of the heuristic value. Right. That is the advantage here. So A star more efficient than the optimal UCS. So all means the constant similar to UCS, and BFS is optimal because always expand the shallowest and unexpanded node. Hence the heuristic search find the optimal solution than the blind search. Yes, UCS is the uninformed search. Uniform cost search, sorry. Uniform cost search. UCS is the uniform cost search. That is this one. First one that is we did uniform cost search. This one. Uniform cost search. UCS. Okay. I hope you are happy. Yes, now these all the question whatever we did yesterday, I am showing you back those question, and now all these question will be easy for you. This was the question, and most of the algorithm already we cover here. This all the algorithm you can see. Breadth first search, depth first search, base first search, greedy, recursive, A star, iterative depending search, uniform cost search, minimax, alpha beta, A and or search, hill climbing, constant satisfaction I told yesterday, min max also, genetic also. These are all done. Okay. K-mean clustering I will try to take if you are interested. If you are interested, lowest cost, uniform cost we take. Lowest cost till now not done. SMA search not done. Branch and bound not done. And K-mean not done. These are not done. Other than that, most of the algorithms are done. Yes, these are already we did. And now just I am showing you those questions whatever we did yesterday. You can see the greedy base first search, A star, recursive, SMA search. You can pause the video and try to think again. The answer is this one. Right, now it will be easy. Here greedy base first search, A star, recursive, iterative depending. Pause it, think it. This is the answer. Branch and bound, stipend, constant and mean end analysis that we discussed yesterday already, and this is the answer. Greedy best first, lowest cost A star. This is the answer. Here A star is optimal when. This will be the answer. Alpha beta search updated everywhere. Here the technique complete optimal for the HN, that is A star. Breadth first search is working on step, and this is the statement. This will be the answer. Here which one is false? This is false. Recursive best first search is efficient in terms of time complexity but poor in space complexity. That was wrong, and why it is wrong now it is clear to you. I hope so. Right? This is now clear to you. Minimax already we did. Genetic algorithm also we did. This is according to the depth first search we are using in topological chart. Heuristic is admissible. Monotonous, that is also you know now. Evaluation selection, these are all the questions we did. Clustering, K-mean clustering we have to do. If you are interested, then I will take a class on the remaining algorithms. Let me know in the comment section. Is it fine? Now all the algorithms are easy. Okay, if you are happy with that, then like, share, subscribe and tell your friends to join the class. And today must, those who did not attempt the mock test, the free mock test, that is your scholarship test is going on already. So many students avail that scholarship. Go to this scholarship test. Here 1 hour scholarship test is there. So 1 hour you can attempt, and if you are getting more than 40%, means out of 60 you are getting 24 marks, then you will get the scholarship from Unify Study. This paid course, that is the batch course, you can avail in 500 rupees only. 2500 rupees course you can avail in 500 rupees only, but the offer is ending today only, that is 21st November by 8 p.m. Those who will attend the course, for them only. 2023 21st November. And if you are taking this one, then automatically these two courses will be available to you, because it is already combined in this course. So paper 1, paper 2 both you can avail using only 500 rupees, and that is only for those students, those who are very much dedicated. Before exam you need our support. For our end we are happy to help you. Thank you. Bye everyone. Chalo. Bye.